Hi everyone. Today I'm presenting my research proposal. My research proposal is fairness for large-scale scaling factor blind phase restoration. Let's start with background. First, let's introduce what is blind phase restoration. Blind phase restoration refers to the process of enhancing or restoring facial images without having knowledge about the degradation process the face went through. Usually the term restoration refers to super resolution, as the task for removing noises is performed very well already. The scaling factor used for the restoration is typically 2, 4, and 8. And here's an example for blind phase restoration. We have an old picture of Albert Einstein, and with a few face restoration models, we are able to restore his face. So now we can see Einstein clearly. Next, we'll introduce two applications for the blind face restoration. The first application is old photo restoration. The blind face restoration technology can help us restore valuable historical photos. The quality of these historical photos are usually poor due to the outdated photography techniques. In this picture, this example, we see that these two men's face are very blurred and we cannot see their face clearly. And after face restoration, we can see their face very clearly. And I assume these two are some historic figures. Next, we come to another application for the blind face restoration. This application is surveillance restoration. In most cases, the surveillance camera used in public places are of low quality. A large-scale installation of such cameras is expensive, and a trade-off between money and quality is made. So the quality of the surveillance gives their way to the give their way to the money. Also, the video captured by these cameras are of great quantity. So you must surveillance like 24 hours a day, right? So they usually go through extreme compression and suffer severe degradation before storing, because storage for large amount of data is also expensive. So in this case, you can see with the help of blind face restoration, in here is AACN, and we are able to restore the suspect's face from the very low quality surveillance video. And either we put a wanted for the suspect, or we compare with the suspect to see if the called suspect is really the suspect in the video. Next, I will introduce large-scale blind face restoration. So, with the development of deep learning, people are no longer satisfied with small scaling factor face restoration. Just as I said, the scaling factor is typically 2 to 8. So GAN-based models are developed to perform large scaling factor face restoration tasks. The scaling factors are now up to 128. In this case, I use the pulse, and you can see that the pulse are able to restore the man's face from a very low definition version. And you can see that this detailed eye and his eyeball and his wing, even some wrinkles, are resolved from like 9 or 12 pixels, and that's amazing and unbelievable. But when the scaling factors are large, the model are heavily depend on prior knowledge, and they produce biased output easily. So next I will introduce the bias problem as our motivation. So the first bias in blind face restoration I'm going to introduce is gender bias. You can see the example here. The ground truth picture or the original picture is a young female, but these three face restoration models think the picture is a middle-aged male. So this is what we call gender bias because the model tend to generate males instead of females. Next, we are going to introduce age bias. So in this case, you can see all these models. The ground truth is a 22-year-old woman. She's a young woman, and the age is not her authentic age, it's his appearance age. So she looks like she's 22. But all the models, they all tend to generate a middle-age appearance faces. So they have a bias towards age. They prefer middle-age appearance. That's what we call age bias. And next bias I'm going to introduce is race bias. And in this case, the ground truth is an Asian woman with a little makeup. But these three models, they generated a white woman instead. But the ground truth is an Asian woman. So we can say that the models tend to generate white faces instead of Asian or other faces. So that's what we call a race bias. With this bias, there are of course approaches developed to combat this bias. The first kind of approach is attributes-assisted restoration. So in this case, this is the work of AICN. It's also the full name is Attribute Augmented Convolutional Neural Network. So in this network, they assume that they have the attributes for every face, and they use these attributes. So the attributes is like your gender, your age, and your skin color, your race, and do you wear glasses or you are smiling, you are not smiling, do you have mustache or beards? So this is what we call these high-level features is what we call attributes of each face. In this work, they assume that they have attributes for every face, and they use these attributes for their generation, their restoration. So with these attributes, they can, of course, generate correct faces instead of biased faces. And using attributes for restoration is, of course, one way to mitigate the biases I mentioned just now. But in scenarios such as surveillance, attributes are hard to obtain. So in real-world cases, for example, surveillance, we use face restoration because the quality is bad and not perceivable. So we definitely cannot tell a person's attributes from the video, and a witness is not always available. So it's sometimes impractical to expect to have attributes in real-world applications. Another approach is attributes involved training. So in this case, this is the architecture of debiased phase restoration. In debiased phase restoration, they want to address the bias, or they want to combat the bias for gender and age. So it's a natural thought to involve these attributes in their training process. So they involve gender representation, hair and age representation in their training and generation, and they use loss for attributes to uh, to supervise the network to learn the attributes for each phase. The involving attributes in training is of course an approach for fixing the bias. However, some attributes, such as race, are missing in most phase super resolution datasets. And it is also expensive to label these phases one by one manually again. So it's kind of impractical when you want to address you want to solve the race bias problem when the dataset is not available using the attributes involved training approach. And another thing to mention is that when you have too many attributes to balance, such as you have like in this case it's gender and age is only two attributes. If you have more attributes like if you involve age or other attributes, and the model might be not so precise and it might be less practical. So after talking about motivation, we are coming to the goal for our projects. The first goal is very intuitive and simple. It's combat the bias for large scaling factor and phase restoration, and create a fair and authentic large scaling factor blind phase restoration model. Uh, so there are several works. There are only a few works that address the bias problem. So our goal is the same with them, is to address the bias problem. And another goal is to build a fewer label required large scaling factor blind phase restoration training pipeline. So as I mentioned just now, the label or the attributes for phases are not always available, especially in real-world cases. And for the training datasets, there are also some important labels are missing. For example, your race and skin color, or sort of something like that. So we want to build a level-free training pipeline for the blind phase restoration. Next, we will talk about some high-level ideas. The first idea is phase feature-aware restoration. We want to utilize some low-level visual features instead of semantic features or attributes to restore phases. So in the works for super phase restoration, they typically take advantage of semantic features. It is attributes. For example, your gender, age, whether you wear glasses. They want to use these features to help restore correct phases, but they sometimes ignore some low-level visual features. So if we can utilize these ignored low-level visual features, we might be able to restore correct phases. And we want to, another idea is non-attribute training. We don't want to use attributes in training, so we extract features that related to attributes instead of directly using attributes themselves, because attributes are hard to obtain sometimes. So we extract some features that might related to them, and we see in which to what extent they are related, and we use these features for training instead of using these high-level attributes. These are basically the idea of a project, as we will see the specific system architecture and technical components. You can see here for the main body of our design, we use a GAN-based generator, and because GAN-based generator is able to generate very large-scale pictures, and it is used in most of the works for large-scale face restoration. So we just use that, and we don't develop something else. But for the important design is feature extraction model. We use feature extraction model to extract some low-level features from the input image or the input faces first, and we took these features to the feature fusion and control model, and after processing these features, we use these features to guide the GAN model to generate a correct face, a higher resolution version of the face. And for the training, we use the same feature extraction model to extract the same features from the generated from the generated faces. So we can use these features to supervise our network, to guide the network to learn these features. So I call this feature-aware training. That's another. This is to address the dataset problem. And apart from the generated the face restoration part, we also need an attribute and quality assessment design, and we will use this design to measure how good the network is when addressing the attributes bias, and we also want to use the quality as good as possible, and we will measure its like PSNR and SSRM, and we also can use some like an IQE approach to assess the quality of the generated image. So last is the timeline for the whole project. First, I want to collect some basic datasets, and I also want to collect some model components such as GAN and some baseline blind face restoration models. After I collecting them more, I want to implement assessment framework for further use, because I want to use the assessment framework to set up a baseline first. We use the baseline models and the assessment framework to set up the baseline to see how they are, to what extent they are biased. And we will process the dataset if necessary. And then we will implement the design for the model. We will especially implement the feature extraction model, and we will train the whole network. And in the end, we validate the result using the assessment framework and compare our model with the baseline models. That's all for today's presentation. Thank you.